Let's take a look at question 14. I'm going to solve this by factoring. Let's refresh your memory first on the zero factor property. Some books call this the zero product principle. They have a lot of different names. They kind of all revolve around the same idea, though. This says if you got p times q is equal to 0, where p and q can be anything. It can be binomials, monomials, a number, an x, whatever. Then you can set each factor equal to 0. So I set p equals 0 and q is equal to 0. Now I like this name the best because first thing 0 tells you have to have 0 on one side. The second part, factor, that tells you need to factor the other side, which works very well in algebra. So let's look at this problem. Got negative 6x squared minus 7x plus 3 equals 0. Our first method of factoring we're going to use is GCF. Whenever your first term is negative, you always want to factor out a negative. And that'll flip the sign of everything inside. So it becomes 6x squared plus 7x minus 3 equal to 0. Now if we look at what's inside the parentheses, we got x squared, x, no x, and there's a number before the x squared. That's the key number. We take our number at the beginning times the number at the end, so we'll take 6 times 3, and we're ignoring signs, so we ignore the negative on the 3. It gives us 18. We handle signs later on. Then we come up with 3 columns. The p column, we write down a little product to give us 18. We got 1 times 18, 2 times 9, 3 times 6. In the sum column, we add those together. 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 is 9. In the difference column, we subtract them. 18 minus 1 is 17, 9 minus 2 is 7, 6 minus 3 is 3. The number we're looking for is a number in our middle term, which is the 7. So I'm going to use 2 and 9. Negative 1 doesn't change anything, it just keeps carrying down. And with the key number, we rewrite our middle term using those two numbers in the p column. Larger number in the p column, which is a 9, is going to be the same sign as the middle term always. Middle term is positive, so this is a positive 9x. Now, if the number I circled in the s column, there'd be s for same signs, both positive, both negative. If it's in a difference column, d for different signs. One's positive, one's negative. Since I already said 9 was positive, that must mean that 2 is negative. Factor by grouping. First group has a 3x in common, and that leaves us 2x plus 3. Second group has nothing in common, but my first term's negative, so I'll factor out a negative 1. And that gives us 2x plus 3. Now they both got a 2x plus 3, so I factor that out. And you can cross these out to see what goes in your second set of parentheses. What isn't crossed out goes in there. So 3x minus 1 goes in second. Now, if I set, we got 0 one side, we got the other side completely factored. If I set the negative 1 equal to 0, I'm solving for x, that doesn't go anywhere. You can cross that off. You never set numbers equal to 0 in this particular situation. We'll set each factor equal to 0, so I'll set 2x plus 3 equals 0, and I'll set 3x minus 1 equal to 0. Then to solve these, take the 3 to the right side, becomes a negative 3. Take the negative 1 to the right side, becomes a positive 1. Divide both sides by the number in front of your x, which is 2. And that gives us x equals negative 3 halves. This one, divide both sides by 3. And we get x is equal to 1/3. Negative 3 halves, positive 1/3, negative 3 halves, positive 1/3 would be D as in David. And that's our answer.